My name is Craig Martell. I am the Chief Digital and AI Officer for the U.S. Department of Defense. We're a new organization that's a merger of four prior organizations, the JAIC, the CDO, a team called Advana, which is an analytics team, and then the Defense Digital Services, which is our Tiger team that dives in and helps in sort of urgent situations. I've been on the job for 4 months. Before I took this job, I ran machine learning for Lyft, which is a competitor of Uber. I don't think they're in Europe, so it's a competitor of Uber. Before that, I worked for Dropbox and LinkedIn doing AI. And before that, I was a professor of machine learning at the U.S. Naval Postgraduate School. So I'm bringing to the problem both sort of an academic view of what AI is and where it's useful, and an industry view of the right way to do the practice. And here, it's hard for me not to wander. Does that still work? Does that still work? No, I guess not. And here's what I've figured out. I don't think most of us actually want as much AI as we say. I think most of us think AI is some, or maybe our bosses, because I don't actually know the makeup in the room, so I'll blame our bosses. Most of our bosses want some magical pixie dust called AI that they can sprinkle on things that will automatically solve the hardest problems in the world and alleviate the need for people to do it. Does that sound about right? Okay. That's not true, right? That's not what AI is. How many people feel confident if I ask you what is AI? How many people feel confident giving an answer to that? Not a lot. That's good. Okay, raise your hand. Raise your hands proudly if you do feel confident. Great. Somebody shout out, what's AI? You all raised your hands? What's AI?
I'll know it when I see it.
See, that's the problem. Anybody?
It's a whole raft of technologies. It's what you want it to be.
See, that's also a problem, right? So let me give you a very practical answer for me for what AI is. And what I really mean is what's machine learning, because it is a different question. And let me just give you a little hint. The term AI was specifically invented to get funding. It was specifically invented by John McCarthy in the 50s to get funding from DARPA. That was the purpose of the term. And some people are actually trying to create artificially intelligent things, but that's not what we call, the things that we call AI really, let me say that slightly differently. The things that we call AI that are successful really are machine learning. And machine learning is simply statistics at scale. It's really important that we, and I know you're going to tell me deep learning is not statistics, it's regression. That's all fine. But it's functionally, we count a bunch of stuff from the past. This is really important. We count a bunch of stuff from the past. We build a mathematical model based upon that stuff from the past, and then we use it to predict the future. That's all it is. Why has it gotten really successful? Number one, we have massive compute power now, mostly driven by video games, but we have massive compute power. And number two, we have massive amounts of data, because every time you download an app, every time you download an app, you're giving away all of your data. And they're using that data in aggregate to be able to make predictions for future behaviors. So I want to say it again. Machine learning, which is the AI that works. I'm sure I'm making somebody angry. I don't care. I don't care at all. The AI that works is machine learning. And machine learning is statistics at scale. That's not 100% correct, but it's 87% correct. I thought a lot about it. It's 87. And then statistics at scale means grabbing a bunch of data from the past and using it to predict the future. Okay. Any questions about that? We're good? I'm sorry, I have professoritis because I did it for many years. So, but everybody okay with that? We use the past to predict the future. That's it. Okay, so let's take a look at my hierarchy of needs. Underneath, at the bottom, we have enablers. Well, we need a place to store the data. Because remember, we have a bunch of stuff that we use from the past. Well, that stuff is data. So we need a place to store that data. We need a way to access that data. We need a really robust cloud environment. We need a really robust cloud to the tactical edge. That's a really fascinating problem which we're going to set aside, and we're just going to let the CIOs solve that for us. Anybody a CIO? Okay, that's your job. You have to solve the white part on the bottom. What's that? Okay. On top of that is the quality data layer. So what I discovered after 4 months of being in the DoD is that we're not going to get to this top of this pyramid for quite some time. Now, we are doing AI, and we're doing AI all over the Department of Defense, and we're doing AI all over the Department of Defense because individual contractors are selling us AI all over the Department of Defense. So let's let that continue. So AI does happen. So let's let that continue. But if we want to build a robust infrastructure that allows for AI done correctly, I'll explain that in a second. I only have 15 minutes. I only have 4 minutes. If we want to build a robust infrastructure that allows for AI done correctly, we have to think about it as a hierarchy of needs. We have the fundamental CIO enablers, but right above that is a layer of quality data. Now, remember what I said, it's stuff from the past that predicts the future. Well, it's not just data, it's labeled data. So remember, AI is trying to replace humans or make predictions that humans can't make, but it's stuff that humans care about. So a human being has to say, so let's think about spam for a moment. How do you tell your email system what's spam and what's not spam? How do you label? Yeah, you move it to the spam folder, or you go into the spam folder because someone called you and said, you didn't respond to my email, usually your boss, and you move it back to your inbox. You are labeling your data. You are telling the model, this is spam, this is not spam. This is spam, this is not spam. One more time. This is spam, this is not spam. And that labeled data has to sit in a data layer so that you can use it to train things. Let's say that you've gathered a bunch of, I don't know, Catherine, synthetic aperture sonar information, right? You would want to put that someplace so that when you build a model, when you do AI, that is easily accessible. So right now, is all of your data in one nice, neat layer? No. Everybody's data is distributed all across the place. All over the place, all across the department, all over the place. So the job zero, not even job one, job zero is to get data, as much of it as possible, into a centralized location. It could be a virtual centralized location, meaning it could be a data catalog as opposed to actually moving the data. Let me tell you, the U.S. Department of Defense has greater than exabytes of data. We are not moving it to a central location, right? That would be a very silly idea. But having a layer which tells you where data is, tells you about that data, tells you the semantics of that data, and allows you to label it so that someone else can take the data and the labels and use it, that's really what we need. That's job zero. Okay, so now we have, imagine we snap our fingers and that's done. Now we have nice, clean data from all over the department, from all over your militaries, in a nice, organized fashion. Okay, should we build AI next? I don't think so. Because I think the vast majority of problems that you want solved is really just a nice, clean analytics dashboard. You want to know how many tanks you have. For NATO, for example, wants to know how many things each country is contributing and when they're going to be where, and if there's been attrition, and if how many countries are sending things to Ukraine versus not, right? So none of that is machine learning. None of that's predicting the future. That's simply counting the things that you have and being able to see it nice and clearly. And I want to drive home this point. Getting the data right is awesome. And then on top of that, being able to have decision makers clearly see what that data says. So an analytics layer, that middle layer, an analytics layer, I think that's 80% of the problem. I think most people just want to see their data and what their data means. When I've been going around the department asking people, what is it that you want? Nobody says, I want to be able to predict things. Very rarely. Almost everybody says, I want to know what I have. I want to know what's going on. I want situational awareness. So in our hierarchy of needs, the first thing we need to do is get the data right, assuming the cloud's there. The second thing we need to do is build a really strong analytics layer. And finally, after we snapped our fingers twice and all of that's done, only then do we want to think about AI. So let's give an example of AI. Someone give me an example of AI that an AI model that they've built or contracted. Automatic target recognition. For, you were going to say something else? For mines. That's great. So now you have some inputs into a sensor, and you want to predict whether it's a mine or not. Is that a fair statement? You want to predict whether it's a mine or not. That's great. That is an excellent AI example. To do that, you have to have gathered a whole bunch of data about mines, put some labels on it, and then built a model. And that model is that piece in the middle. Remember, we have the past, we build a model, and we predict the future. For the AI layer, we started off by building the pipeline that allows you to build a model. I don't think, however, that most models that are going to be used by the Department of Defense should be built by the Department of Defense. I think most models that we're going to use should be built by contractors or experts or academia or our partners. We should allow for models to come from everywhere, because we are not training experts in AI. Some of us are, but mostly we're not training experts in AI. At best, we're training AI practitioners, people who understand that you gather labeled data, you build a model, you predict things. And I don't know if we need a bunch of PhDs in machine learning to be able to do warfighting. I think we'd rather have warfighters who interact with a set of PhDs in machine learning, and that set of PhDs in machine learning builds those models for us. So what we're thinking about is, what's the scaffolding around the model? Okay, what do I mean by scaffolding? So I have a bunch of labeled data. I'm going to pause for a second. Has anybody seen the movie Coded Bias? Coded Bias. Is that Coded Bias? It's a movie about how facial recognition is biased in its predictions. It's a really fascinating movie. I'll tell you the story very quickly. It's about an undergraduate who went to MIT, and she was black. She is black. And she wanted to build a facial recognition system. She wanted a mirror that would judge her mood and then tell her things to make her feel better about her day. I think it was that. See the movie, I might have got some of this wrong. But the facial recognition did not work for her face at all. It wouldn't recognize her face. But when she took a drama mask, an all-white porcelain drama mask, and put it over her face, the facial recognition system instantaneously recognized her face. Okay, is that model biased? No, the model's not biased. It's just counting the past to predict the future. It's the past that was biased. So all of the data that was gathered to build that facial recognition model was gathered in the 60s, 70s, and 80s. Well, what do you think the machine learning community looked like in the 60s, 70s, and 80s in the United States? A bunch of people that look a lot like me, old white men, right? So the models, she did this great research. It's a great movie. She did this great research, and it turns out that those older facial recognition models worked really great for men, for white men. But for women, so I'm going to make up some numbers. They worked about 97% correct for white men. For women, they worked like 89%. For white women, they worked like 89% correct. And then as your skin got darker, they worked less and less well. So she discovered this, and it's, again, not the AI itself, it's the data that trained the model that was biased. And then there's a great story about how different countries are using this older facial recognition systems to actually detect people on the streets. But that's a fascinating sociological, watch the movie. But what she did is convince companies like IBM and Microsoft and Google to add more data to their training data so that their model was no longer biased. And she did that. And now the facial recognition models that they're using aren't biased. Okay, why am I saying that? That's part of the scaffolding around the model. It's not just the math to build the model. The math to build the model is really well understood by nerds all over the world. It's really well understood. But understanding whether the data is biased or not is extremely important if you want to do responsible AI. So we're thinking really hard about the scaffolding around the model, which is getting the data right on the left side of it. He said 3 minutes left. It'll never, not a chance. Getting the data right on the left side of it, that's an interesting sentence. Getting the data correct on the left side of the model, the training of it, and then getting the monitoring of the model correct on the right side. What do I mean by monitoring of the model? So you know the phrase that you don't know, no plan survives first contact with the enemy, right? No model survives contact with the world. Why? Because it was trained on the past, and the world has changed. And the world changes all the time. So I can instantaneously ship a model, and unless the world is static, and nobody gets this piece, and it's extremely important. When I say nobody, I mean even industry still struggles with this. When I ship a model, it's only useful if the world doesn't change, if the world is exactly like the past. The world is going to change. So you have to build a modeling apparatus that measures, are the features, is the input information that I'm using to predict things, is that distribution changing? Is there distributional drift in my input? If there is distributional drift in my input, that model's not as good anymore. Another way you can detect that the world has changed is that there's prediction drift. That I was calling 30% of things spam, and now I'm calling 80% of things spam. Well, if that happens, something's changed. Your emails look very different. That's a really good sign that you need to rethink about your model, retrain your model. And for me, all of this has to do with, I can't believe I'm going to say this, all this has to do with acquisitions and contracting. Why? Because when we contract AI systems now, we never specify in that contract, you must build model monitoring into the system. You must build retraining into the system. You must build a feedback loop into the system. Let me give you an example of why you need a feedback loop. Let's use as an example, am I talking too fast or am I okay? Good, okay. Negative 10 minutes? I'll stop after this. Let's use as an example search and rescue. Okay, so you have a plane and you're looking for people on the ocean, And it's very hard even for humans to visually detect whether that's a raft or somebody in a life vest or just light reflecting off of a wave, right? So the system says, look at this, look at this, look at this, look at this, look at this. And what you do is say, no, 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 yes, no, 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 yes. So your energy is attuned to what the system is offering you, right? And when the system gets it wrong like that, it's called a false positive. The system is saying falsely, that's a positive. That's something you care about. That's something you care about. That's something you care about. And that's where all of your energy goes. But the more dangerous things, let's talk about targeting. Let's switch it to targeting. I give you a queue. I give you a queue of potential targets. And you say, good, 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 nope, not a target. Good, 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 nope, not a target. Good, 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 nope, not a target. Okay, that's great because false positives are easy to find. Here's all the things the system called positive. Those are all true positives. That's a false positive. That's a true positive. That's a false positive. The danger is the false negative over here. The thing the system didn't call a positive, but actually is. This is the thing that's going to shoot at you that you're not looking at. So part of that scaffolding is the kind of training necessary to not just believe the system. Because the system is statistically making a guess, and some of the things it gets wrong are it calls some things targets that are not targets, but other things it gets wrong is to call things not targets that are targets, that are going to shoot at you, right? So we haven't spent any time as a field thinking about training and the interface between you and the system so that you make sure you keep paying attention over here. Why? Because because war fighting is hard. War fighting takes a great deal of energy. And you want, not just war fighting, just living the lives that we live takes a great deal of energy. And if you can focus my energy and save me some time, that's fantastic. But part of that scaffolding around the model is training people to not just look at the things the system is saying, but making sure people are still looking for things the system missed. And then when it missed it, you have to be able to say, you missed this, and have that feedback into the model to make the model better. Okay, so in short, in my negative 10 minutes now, I told you I'd never make it in 15, right? We're thinking about this as a hierarchy of needs. The first thing we need to get is a great cloud infrastructure, and John Sherman, our CIO, is working really hard at that. The next and the single most important thing, in my opinion, is getting the data right. If you have to pick one layer here that's in the CDO box, get the data right. That's the most important thing. Then most of your use cases are probably going to be analytics use cases. We're discovering that most of our use cases, even though people call them AI, are really just analytics use cases. And finally, when you do AI, it's not about building the model. That's actually free and easy these days. Like, Google will just give you the algorithms. It's just building the model is not hard anymore. It's making sure your data is well balanced and responsible and not biased, and monitoring that model after deployment. And we as a field are starting to think hard about the responsible AI part, the part on the left, but nobody's thinking about the part on the right. And so part of what I think our team's job is to do is to think about that scaffolding. But I'll be honest with you, most of our energy right now is on the quality data layer. Okay, thanks for your time.